Today we want to have a closer look at the 2026 F1 regulations and how teams are approaching them. The 2026 regulation change is the biggest in F1 history. Usually either drivetrain or chassis rules are changed, but this time everything is new. So how do teams start designing a new car from scratch? How do they make big conceptual decisions? And how do they read the rules? The first thing is you go to the official FIA website and download the latest technical regulations. At the top, they tell you the version and publication date because these regulations are updated frequently and teams need to stay on top of things. Pink text is showing you changes of previous versions. In Article C1, the regulations tell you from the beginning how F1 works. Article C2 defines fundamental dimensions of the car, and that's important because the regulation boxes we are about to design are based on these fundamental dimensions like wheelbase, cockpit position, and so on. In Article C3, the regulations define aerodynamic components. The way how these regulations are written is different since the 2022 season, when the Ross Brown-inspired rule set came out. So, for example, for the floorboard, they only say it needs to lie in its entirety within reference volume floorboard. If you want to know where that is, you have to go to the back of the regulations, Appendix C2, where all reference volumes and surfaces are defined. And here, in Article 7, we find the definitions for the floorboard, which gives you points and directions to design the box. So the problem, just like for the 2022 cars, is that only someone who can design these boxes really knows how the car will look like. And the problem of most news magazines and journalists is that they are no designers themselves, so they have to rely on others. And if you don't have these boxes in front of you, it's hard to understand the rules. But here, I can show you everything step by step, so you can design it yourself and we can understand the regulations fully. So let's go back to Article C2, Fundamental Dimensions. First of all, the coordinate system. X is the longitudinal axis and points to the rear. Positive Y is pointing to the right and positive Z points up. We designed the car on the left-hand side, so all Y values are negative. There are 6 important planes we need to design first. XF is the front axle. XR is the rear axle, so this is the wheelbase, and here the regulations tell us that the gap between both must be equal or less than 3,400 millimeters. So we are free to run a shorter wheelbase. Another plane is XA, which is the forward limit of the survival cell. Here we need to decide the front wheel position, because XF is an offset of XA, and we can choose between 0 and 150 millimeters. The next crucial dimension is the cockpit position. Here, plane XC is the rear of the cockpit, so the headrest position if you like. And we can choose between 1,830 and 2,030 millimeters from the start of the survival cell XA. Then we have the rear bulkhead position with the plane XPU, which is the forward face of the engine. The gap to the rear of the cockpit should be at least 360 millimeters, so this is where the fuel tank will sit. And at the back we have the plane XDiff for the rear differential, which sits 60 millimeters before or after the rear axle. For further design work, it makes sense to create the center point for each one of these planes. We can now go to each one of the articles about reference volumes and design them. Article 16 about the side pod inlet, for example. We design these points on the plane and you can see that the X value is based on XF. So if the front axle is moved, this regulation box moves as well. Once we have these points, we draw lines between them and extrude the profile to Z600. So this is our so-called reference volume side pod. Another example is the reference volume for the rear wing profiles. And here we can see one thing the regulators like to do now. They give you only 2 points which define a box in space. It is some work to design it for the first time, but once you have the design you can copy and paste it every time you need it. The X coordinates are based on XR, so if the rear axle moves, also this rear wing box moves. For each one of these paragraphs we create a new folder, so it's very easy to understand how we designed it. That's important so also colleagues can understand it quickly, which keeps our team's development speed up. Next step is to design a plane for 3 points to trim the volume. And the result is our reference volume rear wing profiles. And this is how you go through each article to create all regulation boxes. Plus, the new regulations give you a table at the end with lots of additional boxes, all of them defined by just 2 points. So if you have your standard design, you just copy and paste the folder and change the coordinates. That way, they can very quickly and efficiently define boxes, and there is nothing you could misunderstand. So if you did all this, you end up with a number of regulation boxes which show you pretty clearly how the car will look like. And since we designed all of these boxes based on our fundamental dimensions, we can now change them around to see how the reg boxes change. First of all, the wheelbase. Do we want a short or long wheelbase? A short wheelbase makes a car smaller, which means less material and less weight. But a long wheelbase gives you more floor area and more potential to produce downforce. So it's a good idea to go for the longest possible wheelbase of 3,400 millimeters. Next one is the cockpit position. Open-wheeler formula cars create a huge messy front-wheel wake. If this wake is hitting downforce producing parts instead of clean air, you lose a lot of downforce. So teams try to push this wake as far outboard as possible. The regulators want the opposite. So in 2022 they took the barge boards away, and the F1 teams utilized the outer floor strake and large wide side pods to push the wake outside. Now in 2026 the regulators even demand an in-washing board. So teams will try everything they can to turn this into outwash. So it makes sense to bring the cockpit further forward, to bring the thickest point of the monocoque closer to the front axle, which will increase pressure behind the front wheels and push the wake more outside. Another interesting thing we can see here is that the upper side of the monocoque box is defined by a huge cylinder, whose center is linked to the cockpit position. So by positioning the cockpit further forward, the reg box at the nose gets a lot thicker. And if we additionally position the front axle further back, we get a 150 mm thicker regulation box at the nose of the car. So that allows teams to design a 150 mm higher nose. And why do you want that? Because you want to disturb the airflow as little as possible. You want more space for the front wing, and you want more clean air for the floor entry. So by setting these fundamental dimensions right, you could get significant aerodynamic advantages. If we look further through the regulations, we can see that, unsurprisingly, we find a flat floor again. But the diffuser is really long and really big. The boxes for rear wing profiles and beam wing are very thin, so there is no extreme camber possible. And we can see that a single pillar design for the rear wing is no longer possible, since we have 2 regulation boxes there now. So things are getting interesting now. Getting the fundamental dimensions of their cars right is important for F1 teams to gain aerodynamic advantages. And we can be excited to see which team took which development direction. I hope you liked this first insight into the 2026 F1 regulations and stay tuned for more.